right. If you guys think back to when we were first learning factoring, I gave you like a flow chart thing. Salmon colored paper, maybe? I think we had a conversation about the color of that. So that paper does have our new stuff already on it, where we've already done difference of squares, but above two terms is also the difference of cubes. So I showed you kind of basically what it looked like, and then I broke down how to do it. I wrote the word SOAP on there to help refresh your memory on the signs. And then we also talked yesterday about four terms. So group first two, group last two, factor GCFs. You're going to have a common parenthesis and then what's left over. All right, so that's kind of, it's on your flow chart. It's on a colored paper, which means what? On the final exam, not the test, final exam. Okay. All right, so solve by factoring. All right, we're going to still factor, but now we're going to actually solve. We're going to have equal signs in there. So first thing, put equation in standard form. You want to get it equal to 0. All right, you will factor completely based on whether it's quadratic, quartic, factor by grouping, or sum and difference of cubes pattern. So all the stuff we worked on yesterday, you got to figure out which one it is. You're going to factor it completely. Then you will set each factor equal to x. We're going to set each one equal to 0 to solve, just like we've always solved factoring. So nothing's changed there. We're going to factor. Whatever our factors are, we set them equal to 0. We're going to solve. Just sometimes the solving gets a little not so pretty. Right? Remember, the blank of the polynomial is equal to the number of solutions or zeros. How do we know how many answers there are? Highest exponent, which is called the degree. So remember, the degree, which is the highest exponent, tells us how many answers we should have. This is a great chapter where it helps you to look back at the original problem and then how many answers you were given me. Some people have an x cubed and they've written down 5 answers. I'm like, really? Like, just do that check. Make sure you're not like having too many or not enough. If an equation cannot factor completely to linear factors, meaning it doesn't factor down to like x plus 3. Like it might finish with x squared plus 7, right? That doesn't factor any further. So then you're going to have to use the quadratic formula or finding square roots when necessary. So it's not just easy solve a basic equation to solve these. Sometimes we have to use some of our methods from the last chapter. Solutions or zeros may be blank or blank. I agree, but not what I was looking for. It could be real or imaginary. Fake. I like that. Yeah, they could be real or imaginary. When do we end up with imaginaries? Negative square roots. Good. That means you pull that I out. All right. So let's start with quadratics. We'll start with stuff we know just to refresh our memories a little bit. So number 1, what do I have to do with it first? Before that, set it equal to 0. Good. So 2x to the 4th. I'm going to move the 2 terms over just because that one's already positive sitting there. So minus 5x cubed minus 12x squared equals 0. All right, and then somebody had said, what do we do next? GCF, which in this case is just an x squared. So we have 2x squared minus 5x minus 12. Okay, pull out your GCF. Factoring further. My last one's negative, so I know my signs are opposite. All right, options for A, just 1 and 2, so 1x and 2x. Options for C, we're going to have 1 and 12, 2 and 6, 3 and 4. One of those I can eliminate right away. Which one can it not be? Cannot be 2 and 6. If I put a 2 or 6 in here, it's going to have another GCF sitting in here, so I know that one can't work. You want to go 1 and 12 or 3 and 4? 3 and 4. Where does the 3 have to go with the 2? So if you check, that gives me 8x minus 3x. Flip my signs. Good. All right. Once it is fully factored, we set each factor equal to 0 and solve. So what is baby brother going to give me? Just 0? two zeros because he was x squared. And then x minus 4 equals 0. And 2x plus 3 equals 0. I know we're kind of beyond the point of writing this all out, but I'll write it out just because I know it's coming. So solving this one, we'd add 4. So x equals 4. Good. Subtract here. And divide by 2. So we get negative 3 over 2. And then do that little mental check, right? Go back to the beginning. That was x to the 4th. I have 4 answers, so I know I have all of them. All right, again, should this part have been new? No, it should not. All right, I'm going to skip the next one. Let's skip 3. Let's jump to 4. So number 4, what do we do first? Good. Subtract that 64. So 9x to the 4th minus 64x squared. Then what? GCF. Guys, we've got to look for the GCFs first. Remember we talked yesterday that people struggle knowing which type it is because they don't take out those GCFs. So I can take out an x squared. So 9x squared minus 64. And then how does that factor now? Bless you. 3x plus 8 and 3x minus 8. Those are my favorites. So what do we get for answers? X equals, what's baby brother give me? 2 zeros. And then what about those factors? Good. Now, I am a lazy mathematician. What's a faster way to write negative 8/3 and 8/3? Yeah. If it's me, instead of writing it separate, you can, but I would write it as plus or minus 8/3 just because it's faster and easier to write. And it shows plus minus, so I have one of each. Okay, just so you know that will show up. Questions on the basic quadratics? We should be okay at this point. You guys did really well on factoring. All right, let's jump then to Cortex. Let's get into the new stuff. All right, so number 6. Carson, what do you want to do first? Carson with a C. Good. Set it equal to 0. So x to the 4th plus 2x squared minus 15 equals 0. How do you factor Cortex? No. Is this the SOAP? No, that's 2 terms of cubes. I just factor it like quadratics. Instead of x and x, I'm going to have x squared, x squared. Yeah, Cortex aren't bad. My signs are opposite, so plus minus. Options for A, it's just going to be x squared and x squared. Option for C. And which one works? 3 and 5, which one's positive? The 5. So plus 5 and then the minus 3. Now, here's where things get just a little tricky. Not bad if you remember back to the last chapter. When I set these equal to 0, x squared plus 5 equals 0. Bless you. X squared minus 3 equals 0. Some of you are seeing it already, aren't you? When I solve this and I subtract 5, I have x squared equals negative 5. How do you finish? That takes the square root of both sides. So what does x equal? It'd be plus or minus I radical 5. The square root of 5 is not 5, right? Isn't that great when math kind of like comes back again? You're like, oh my gosh, I remember how to do this. It was useful, right? All right, and then solving the other one, we'll have to add 3. So x squared equals 3. Take the square root. Plus or minus square root of 3. What degree was this original problem? Fourth, what's its fancy name? Quartic. So 4 answers. Do you have 4 answers? Yes. See the plus minus? So I have a positive I radical 5, a negative I radical 5, a positive radical 3, a negative radical 3. I do have 4 answers. Okay. How about number 7? Okay, set equal to 0. So that's 3x to the 4th. Wait a minute. Where does it go? In the middle. Good. Make sure it's in the right order. So minus 13x squared plus 4 equals 0. So when you move things over, make sure it's still in standard form. Is there a GCF? Nope, there's not. So we'll set up our parentheses. What are my signs? Both negative. Options for A, it's just 1 and 3. So 1x squared and 3x squared. Just don't lose those squareds. Then you want to go 1 and 4 or 2 and 2? I heard a lot of different answers there. 1 and 4. In that order, 1 and 4? Oh, it does matter. 4 and 1? Good. Yeah, if you check this, that's going to give you negative 12 minus 1, which gives you the negative 13. All right. Now, here's where I'm not going to be real nitpicky on you. Do you see the difference of squares sitting there? Do I have to factor that further when I'm solving? I don't have to, because I can still solve from here. So x squared minus 4 equals 0. 3x squared minus 1 equals 0. Okay, so after you factor, we set each one equal to 0 like we always have. When I go to solve here, I'll have to add 4. So x squared equals 4. Take the square root. And what does x equal here? Good, plus or minus 2. It's imperative we don't lose those plus minus. If you take the square root, your answer is plus minus. Oh, this one's fun. We're going to add 1. So 3x squared equals 1. Some of you see it coming, don't you? Divide by 3. So x squared equals 1/3. Why did I say this was fun? How do I square root a fraction? Top and bottom separately? Oh, there's the eye rolls. Now we saw it. We know what's coming. So x equals, what's the square root of 1? 1. Okay, that one gives me a 1. Square root of 3? I can't do. So what are we going to have to do? Multiply top and bottom by radical 3. So we get plus or minus radical 3 over 3. Yes, love that. Come on, that's not a little fun? A little bit? I find it, I don't know what it is. It's like, hey, something we learned in the last chapter actually, like, wait, applies to what we're doing now? Like, oh my gosh, who would have thought? Shut up, I do. All right, guys, why don't you try number 8 on your own? All right, guys, let's go ahead and go through this together. So we set it equal to 0 first. So 6x to the 4th plus 11x squared minus 2 equals 0. Was there a GCF? Nope. All right, so no GCF. Hopefully you looked for it, though. Set up your parentheses. Last one's negative, so they are opposite. We can either go 1 and 6 or 2 and 3. 1 and 6, so x squared and 6x squared. 1 and 2, I know the 2 cannot go here. It would have to be here. That's going to give me 12x minus 11, or minus 1, so that's correctly factored. Double check your work, guys. Make sure it's factored just like that. We set each part equal to 0. 6x squared minus 1 equals 0, and then we have to solve. All right, so we subtract 2, and then take the square root. So x equals plus or minus I radical 2. There are 2 of my answers. We'll add the 1, and then we have to divide by 6. And then take the square root, top and bottom. So x equals plus or minus 1 over radical 6. Cannot leave a radical on the bottom. So we get plus or minus radical 6 over 6. Come on. All right, how are we feeling so far? Pretty good? Okay. And then you forgot the I. That happens. That happens. All right. Do we need to see any more Cortic ones, or are we ready to move on to the next part? Anybody need more Cortics? Speak now, forever hold your peace. All right, let's jump to factor by grouping. Factor by grouping. So now we're looking at things ahead for terms, right? So same idea, we want to start by setting them equal to 0. So x cubed plus x squared minus 3x minus 3 equals 0. All right, I feel like I lost half of you right now. Are we okay? You with me? Do we need to go back to more Cortex? We're getting there, boy. Relax. All right. So set it equal to 0. I have 4 terms. That means it is grouping. So I'm going to group the first 2, group the last 2. What is the GCF in the first set? X squared. So I factor that out. We get x plus 1. GCF in the second set? Negative 3. What happens when I take out negative 3? X plus 1. What is my common factor? X plus 1. So if I factor that out, what do we have left? X squared minus 3. That's factored. Okay, that's factored. How do you solve? Set them equal to 0. X plus 1 equals 0. X squared minus 3 equals 0. So we get x equals negative 1. Here, I'm going to have to add. So x squared equals 3. Take the square root. So x equals plus or minus square root of 3. That one wasn't as bad, right? Do I have 3 answers? It's cubic. Yeah, I got 3 answers. All right, try 13. All right, guys, so we need to set it equal to 0 to start. 4x cubed plus 4x squared minus x minus 1. All right, we have 4 terms, so we know that is grouping. GCF in the first set is 4x squared. What do we have left? I see a lot of you struggling when you're taking this out right here. I have x what? Plus 1. A lot of you are losing that plus. You're like, yeah, I took it out. I have nothing left. But remember, you're dividing that. So 4 divided by 4 is 1. GCF in the second set, negative 1, which leaves us with x plus 1. So then I have this common factor of x plus 1. And the leftovers is 4x squared minus 1. You could factor that further. That is a difference of squares. But if I'm asking you to solve, could you just solve it? Yeah, you can go either way. Doesn't matter to me. So we're going to have x plus 1 equals 0. 4x squared minus 1 equals 0. So x equals negative 1. Here, we'll have to add the 1 and then divide by 4. So x squared equals 1/4. Square root top and bottom. What's the square root of 1? Square root of 4. And don't forget, plus minus. And my pen jumped to black. They are possessed, yeah. If you square root, you cannot do until you've gotten the x squared totally by itself. Yeah, so you have to isolate the x squared before you can do the square root. What? What's going to happen is you're going to go to do that some other time, and you're not going to take the square root of the number with the x squared, and then you're going to have a world of hurt. All right, let's take a look at 15. We're going to skip 14. Let's look at 15. So 15, it's already set equal to 0, right? Should be good? Okay, it's already set. We're going to group the first two and the last two. GCF in the first set? 6x cubed, not 3. All right, so we have x plus 2. GCF in the second set? 2x. So we have x plus 2. Common factor is x plus 2. Leftovers. All right, we need to talk about how we're going to solve for this, because this always throws people. Here it is. All right, so once you factor, we will set each factor equal to 0, and then this is where hopefully you can kind of see what we need to do with this. All right, the first one's easy, it's just negative 2. But what about that second one? 6x cubed plus 2x equals 0. I take a 2x out. I can factor that further. So then I have 3x squared plus 1. The reason it showed up like that, look at your original problem. Do you see a GCF in the original problem of 2x? Yeah, there was a GCF to start with. Now, this is the one, though, the grouping, is the one I say I don't ever take it out first because it gets in the way. Because otherwise, if you pull out a GCF, then you got baby brother who's obnoxious as can be standing out there, and then you're trying to do the grouping and pull more stuff out, and he is just in the way. Okay, so that is one time I do not pull out a GCF first. Yes? Yes. So when I solve this, we get 2x equals 0. 3x squared plus 1 equals 0. So yeah, baby brother is going to give you an answer of 0. He is an answer. And then 3x squared plus 1, we'll have to subtract the 1. Divide by 3. So x squared equals negative 1/3. Take the square root, top and bottom. Square root of negative 1, just I. And I get radical 3 on the bottom, plus or minus. Am I good? No. Got to rationalize. So plus or minus I radical 3 over 3. Woo! Man, that's fun. Come on. There's at least one in here who thinks that's fun. You made a mistake and told me. I don't know about you guys, but don't you ever finish a problem and you look at it and you're like, I am so smart. You're like, I did that. Come on. You never done that before? You're like, I did that. Then you feel bad. All right, guys, moving on then to sum and difference of cubes. This is the SOAP pattern. This is the one you have to memorize the pattern. All right. So here we go. It's already set equal to 0. There is no GCF. So we'll set up our parentheses. Remember, the second one's a little longer. This is where we use SOAP. Are we okay on understanding when this method works? How many terms will you have? 2. And what degree will it be? It'll be to the third. It'll be cubed. Okay? So if you have 2 terms and one's an x cubed, and there's no GCF to pull out to make it smaller, it's the cube pattern. Bless you. All right, so signs. Same, so it's going to be a plus. Opposite is a minus, always positive. All right, so then we take the cubed roots of both of these. Cubed root of x cubed, cubed root of 27, and then square, multiply, square. So x squared, so x squared, multiply x times 3, and then 3 squared, 9. Okay, Again, that's just memorizing the pattern. All right, when we solve, so I have x plus 3 equals 0. So we know this one, x equals negative 3. Should I try to factor that further? Do you remember yesterday? Will that factor further? No. No. Never. Never, ever, ever, ever. So, since we know that that will not factor further, what is the only method I have left to solve that? Quadratic formula. So x equals, yeah, negative b is 3. All right, guys, I need we all to take a breath and calm down because we're a little out of control right now. So b squared, so negative 3 squared minus 4 times 1 times 9 all over 2 times 1. All right, we have to use the quadratic formula because it will not factor further. Try as you might, it will not. And then I can't use the square root method because I have a b term. So our other option then is quadratic formula. So x equals 3 plus or minus the square root. What do we get underneath there? It's negative 27. We have to take the negative out, and we'll do our factor tree. So we get 3 plus or minus the 3i radical 3 all over 2. Can I divide all three numbers? No. So I am done. If you were to graph this, how many times would it cross the x-axis? Stop and think. Once. Why? Where's it going to cross? It's going to cross at negative 3. Why will it not cross at that other one? It's imaginary. Imaginary answers do not cross. Okay, so if you graph that, it would only cross at negative 3. Okay? All right, take a look at 17. It's already set equal to 0. Is there a GCF in that thing? Probably. Do you notice they're both even numbers? So they're both even. I would start with 2. So we get 64x cubed minus 729. Guys, take a deep breath, guys. This is where people start to struggle. Remember, we were hitting our wall yesterday. All right, so we took out the GCF. Now I'm looking at this. It is 2 terms with an x cubed. Are these perfect cube numbers? If you looked at it from the beginning, if you tried to take the cubed root of 128, it wasn't pretty. But pull out the GCF before you even try to tell what kind of problem it is. All right, so those are perfect cubes now. All right, so SOAP. So same sign is a minus, opposite is a plus, and then always positive. Cubed root of 64x cubed is what? That's 4x. Cubed root of 729 is 9. Then we square, multiply, square. So what is 4x squared? 16x squared. Multiply 4x times 9, 36x, and then square the 9. 9 squared is 81. Will that factor further? No. You know, you laugh at me because I keep drilling this in your head. Somebody's going to try to factor it further, okay? It won't. I'm just trying to drill it in your head. It's not going to. All right, so from here, will baby brother give me an answer? There's no x on him. All right, what do I get right here? What's this one give me? 9 over 4. There's one answer. How do I solve the other part? Quadratic formula. Don't say you don't. You do. We can always solve. So negative b plus or minus square root b squared, oh my, these numbers are huge, minus 4 times 16 times 81 all over 2 times 16. All right, somebody help me out. What giant number do we get in the middle of that? Negative 3,888 over 32. That's beautiful. So what do you do from there? We'll take the I out and do a beautiful factor tree. I'm going to do my factor tree over here just because I ran out of space on that side. Right? They're even scared of it. I don't know. So what is that? 2 and something? I am. It's a big number. So 1944. So 2 and 972. 2 and 486. You betcha I'm doing 2s. 2 and 243. Look, I did that one in my head. And that's 3 and 81. Ah, ha, ha. See, no more calculator. 9 and 9. Oop, don't circle that. 3 and 3. 3 and 3. Oh, that's pretty. Pretty. So, pair of 2s, pair of 2s, pair of 3s, pair of 3s, and a radical 3. So 2 times 2 times 3 times 3 is 36. So x equals negative 36 plus or minus 36i radical 3 over 32. All three numbers can be divided by 4. So I'm taking all of these and dividing them all by 4. So we get negative 9 plus or minus 9i radical 3 over 8. Oh, that's beautiful. What if I told you that I could have went from here to here without any work? Would you want to know how? Yep. Because, I mean, this is beautiful, but I don't want to do all that. I'm lazy. Only to prove a point to you guys. I want you, what's the point? Look at this answer. Look at this answer. What do they have in common? They both have an I radical 3. What else? See these numbers? See how they're the same? See these numbers? See how they're the same? It's always going to happen, guys. That because, okay, she's like, well, this one's a positive and that one was a negative. And she's right. But that comes from the formula negative b. So whatever your b value was, it just flipped it. So let's go through the next one and I'll show you how that works. Okay? I'll show you how the shortcut works. So number 18, it's already set equal to 0. Is there a GCF? Nope, no GCF. All right, so this is SOAP because it's 2 terms. And they are cubes. So use SOAP. So same is positive, opposite is negative, and then always positive. All right, what is the cubed root of 8x cubed? 2x. Cubed root of 1 is 1. All right, from here it's square, multiply, square. So what is 2x squared? multiply 2x times 1 and 1 squared. Okay, so there it is factored. Now when we solve, this one you should be able to do pretty quick. So this one, x equals negative 1/2. This one will not factor further. I would have to use the quadratic formula, but I'm going to use the shortcut. So keeping the quadratic formula in your head, because you still need to know that's what you're doing. So if I have negative b, it's going to be 2, plus or minus. Now what did we notice about the next number? It was the same. And then what else was it always? Not just radical 3, but I radical 3 over 2 times a. So it'll be 8. And then all three of these I can divide by 2. So I get 1 plus or minus I radical 3 over 4. I need you to appreciate where it comes from. All right, take a look at 19. Let's do this last one real quick, guys. So what do you have to do first on 19? Set it equal to 0. Guys. So I set it equal to 0. What's the next thing you always look for? GCF, which is? 4 doesn't go into 54. 2. So we get 27x cubed minus 8. If you're ever not sure if it's the biggest or not, pull it up. Take a look. Is there still a GCF sitting inside there? If there is, you didn't take the biggest one. But there's not. All right, 2 terms with a cube. So that's our SOAP pattern. So we'll set up our parentheses. SOAP, so it's same sign, so it's a minus, opposite, and always positive. What is the cubed root of 27x cubed? It's 3x. Cubed root of 8 is 2. How do I get the next part? Square multiply square. So 3x squared is 9x squared. Multiply 3x times 2, 6x. And 2 squared is 4. Does baby brother give me an answer? Nope. What's this one give me? It's 2/3. This one, will it factor further? No. So I would need the quadratic formula. So negative b is negative 6, bless you, plus or minus, bless you. What do I know this is going to be? 6 I radical 3 over 2 times a, which is 18. And I can divide all three numbers by what? By 6. Bless you. Bless you. So x equals negative 1 plus or minus I radical 3 over 3. Now, here's where students mess up, okay? They get so excited about the shortcut, they decide that they're going to use that shortcut on every time they use the quadratic formula. That doesn't work. All right, that shortcut only works when you're doing cubes. Okay, that's the only time that one works. So kind of trap that in your head, right? If it's the cubed method, right? So it's x cubed, x to the third. That's when you know it's going to be a radical 3. Those work together. Do not use this every single time that you end up using the quadratic formula. Is it possible you use the quadratic formula somewhere else? Yeah. If you get a problem and you get down to an x squared something and you can't figure out how to factor it, didn't some of you like to do that last chapter? If you can't figure out how to factor it and it's x squared, if it's anything other than x squared, it doesn't work. That's why it's called the quadratic formula. Then you can always just go back to that. Because I believe on homework tonight you have a couple, I think there's maybe 2 on there, if I remember correctly, that they won't factor. They're x squareds, but they won't factor. So you'll have to jump to the quadratic formula. Okay? Does this shortcut work on all quadratic formula? No, only in the cubes. Okay, if you're doing the cube method, then yeah, it'll work every time. But don't do that method if it's not a cubed problem.